All right, so today we're going to do some review of trigonometric functions, which I know you all saw in prep last year, but these are not in our formula packet, so we do need to know what all of the different parts mean, so it's worth an extra little bit of review. So a sinusoidal function, right, we got keyword sine in there. It's also called a periodic function because it repeats over and over and over again. And we have two kind of base functions here. We have sine and cosine. Sine, right here, is always going to start on the midline and go up directly. And then if it were negative, it would start on the midline and go down. But it's always starting on the midline. In comparison, cosine is always starting at a maximum. Negative cosine would start at a minimum. So we'll jot that down here. So sine starts on midline and goes up. Cosine starts on a maximum. And then a negative would start at a minimum. And then a negative goes down. So we'll just sketch it here real quick. So negative sine would start on the midline and go down. Negative cosine would start at a minimum. All right. So we have lots of different pieces going on with sine functions and cosine functions. And each of these numbers tells us something specific about the function here. So to start, we have A, our amplitude. So that is this right here. It is the distance from the midline to the maximum. The IB language for midline is often principal axis. So if you see that, that just means the midline also. So we kind of already, a negative A value flips the starting behavior, which we just saw above too. So sine, negative sine starts down, or starts going down, but on the midline, and then negative cosine, as we saw, starts at a minimum and goes up. So the negative would belong to the A value in a trig function, and we'll see some examples of that. All right, frequency is the value for B, so it's the number of cycles between 0 and 360. Anytime we're doing trig stuff, 360 is an important value because it's a full circle, it's all the way around. So the frequency, how many times does the cycle repeat between 0 and 360? And then period is often easier to identify than frequency, and period is the length of a full cycle. So for example, on this graph here, we've got, it hits the midline there, and then it completes a full cycle, and it hits the midline here also. So that right there is period. You'll notice it's not just midline to midline, because that would only be half a cycle. It has to go all the way up and then all the way down. We could also track period by looking at minimum to minimum. That's a full period, or maximum to maximum if we had that also. The relationship between period and frequency, or period and v-value, is that the period is always going to be, that is not what I meant. Period is always going to be 360 divided by B, or frequency, and the B value will always be 360 divided by period. This is probably going to be the thing that you all use the most, since usually it will be easier to find period than it is to find frequency directly. All right, and then the last part is the vertical shift. So how far has the principal axis or midline moved from the x-axis? So this distance, we'll make it all the way. This distance, that is our d value, how far up or down. We write the midline, since it's a line, as an equation. So it'd be y equals d, since it's just a horizontal line. And then the value of d will always be, it's always going to be halfway between the minimum and maximum. So if it's hard to see, or if it's not sketched in directly, we can do minimum plus maximum divided by 2. That's just us finding what's halfway between the minimum and the maximum. All right, so the steps to writing an equation here. First thing we'll do is identify if it's sine, cosine, negative, or positive. Then we will identify the midline or principal axis to get the value of d. The reason we find d first is because it helps us with a lot of the other things. We can see, for example, the amplitude, that was all wrapped into where the midline is. Even looking at where the graph crosses the midline is important for a period. So we'll find that one first. Ooh, that looks like a C. Uh-oh, D. Okay. Next, we'll find the amplitude to get the value of A. So we'll measure from the midline. And then we've got two options for how we're going to find B. We can either count the number of cycles between 0 and 360, or we can find the length of a cycle in the period and use it to find the frequency. Often in context, we'll use the period. The example we have right below us that doesn't have a context, we see it kind of fits nicely with 360 degrees, so we'll go from there. Okay, so when we look at this graph here, I see that it's starting at a maximum. So that tells me right away that this is going to be a positive cosine function. We'll go ahead and find all the things that it tells us to find. So principal axis, that's going to be our midline, halfway between minimums and maximums. This one, it's easy to see on the graph that the midline, or the principal axis, is the line y equals, is that, I blocked it, -1. Next, our amplitude, how far are the minimums and maximums from the midline, and that would be 2. Our y-intercept here, that is 0, 1. And our period, let's see, the length of one cycle. So if we go from maximum to maximum here, that's 180. So that is our period. All right, so when we then go ahead and think, okay, what is A, B, and D? Well, A, that's our amplitude, which is 2. We get to use that directly. B, here's where we're going to use our period to find B, since we see above B is equal to 360 divided by the period. So I'm going to do 360 divided by 180 to get 2. And that is also the frequency, because I can see that in my graph from 0 to 360, I have one complete cycle and then a second complete cycle. So frequency of 2. 2 cycles fit between 0 and 360. But using 360 divided by period gets us the same thing. All right, lastly, our value for D, that is just where is our principal axis, and it is at -1. So when we put this all together, we're going to have, we've got y equals 2 cosine of 2x minus 1. Just putting all of the pieces. Our a value is 2, our b value is 2, our d value is -1. All right. Let's see, what are we doing? All right, example 2. This time we are going to do some sketching. So we can identify the features from this graph. So we'll start with our midline. So that's right here. Midline is at y equals -2. So we'll go on in and draw that. And then next, it's going to help us figure out, okay, where are the minimums and maximums going to be? So that's our amplitude is 4. So the maximums will be 4 above the midline. So 1, 2, 3, 4. I'm going to draw another dashed line. And then our minimums will be 4 below. So we'll draw another dashed line. All right, we have a sine function. So that tells me that if we look back from above, a sine function is going to start on the midline and go up. So we will start on the midline, and then I'll hold off on putting anything else. All right, for our b value is 2. So that means 2 cycles fit between 0 and 360, but it'll help to find the period also. So our period is going to be 360 divided by 2, which is 180. So that tells me 1 cycle is going to be finished at 180. So to get the other points along the way, I know, so for a sine function, it starts on the midline, it ends on the midline. It's also going to cross the midline halfway through. So if we're at 0 and 180, halfway through, it's going to be back on the midline at 90. Since this is a positive sine function, it's headed up first. So it's going to go something like that. We can get the exact points because we know halfway between the 2 points on the midline, it's going to be at a maximum. So that'd be at like 45, which would be halfway in between here. And then same thing down below. So now we have 1 complete cycle. I'm going to do another one just since I have a lot of space left in the graph. So again, I'm going to be back at 360, halfway, halfway, halfway. Can keep it going, wee. And then, let's see, I kind of run out of room for a third cycle, but I can get a start on it. Right, wee. Okay. All right, so there is our graph. Okay, last one. We've got an in-context question here. So we've got Simon exploring tidal patterns. Tides are a really common example or situation that we'll see since they're cyclical. So Simon is measuring the depth of the water at the end of a pier. He finds the data can be modeled by this function here, or x is the hours after midnight. And I guess he was recording this, but Simon's laptop crashes, but he finds a paper with some of his data. So he has this. That's all he's got, but he's trying to determine the values in the equation and interpret them. So things we'll need here, we'll need our value for A, we will need our value for B, and we will need our value for D. The easiest one to find first is going to be our midline. So a reminder that the midline is halfway between the minimum and the maximum, so we're going to average or add and divide by 2, 11.2 and 5 to find what's halfway in between. So 11.2 plus 5 divided by 2 equals, let's see, 11.2 plus 5 divided by 2, we get 8.1. All right, for B, or actually let's do A first, because we just get to measure how far away is the maximum from the midline. So that would be, okay, if our maximum's 11.2 and our midline is 8.1, if I subtract those, I'll get that distance. So 11.2 minus 8.1, that gets me 3.1 is this distance here, or our A value. And then lastly, our B value. So for this one, we don't have the end of the cycle completely laid out for us, but we do have these values for the middle. So we know that this right here is 3, and we know that this right here is 9. And so that part right here represents half of a cycle. So this is 6. And so our entire period would be B, or would be 12. So when we find our value for B, we're going to do 360 divided by the period. And for us, that will be 360 divided by 12, because this right here is half a cycle. It needs to go maximum to a whole cycle, so maximum to minimum is half a cycle. So that would be, let's see, 360 divided by 12 equals 30. All right, questions like this where we are given a graph and we are trying to find the equation in some way. So our equation here didn't actually ask for us for the equation, it just asks us for A, B, and D. But I'll write out the equation just since we have all the pieces. So it'd be y equals 3.1 sine of 30x plus 8.1. When we're given an equation, or when we're given a graph and we find an equation, we can check our work really nicely by graphing it and seeing if we get the same graph that we have. So if I put in my graphing calculator, the function, making sure you're in degree mode, since this is a trig function, it relates to degrees. But if I put in my function, if I adjust my window so it matches the values here, so x is from -1 to 12, y from -1 to 15, and if I graph it, I see, yep, okay, this is looking like that, so I can trust my function. So now we did that first part. We determined the values of A, B, and D. Now we need to interpret them. So I'll interpret them in the same order that we found them. So first we found D, so the midline. So in this context here, so the midline is the halfway point, and it's going to represent like the average depth of the water, because half the time it's above it, half the time it's below it, and it's kind of exactly paired up. So 8.1, that represents the average depth of water at the end of the pier. So the average depth of the water is 8.1, and then what are our units here? Are we given units? That's fishy. We'll go with meters. We'll trust that they're doing the metric system. Okay. The depth, we'll add some words, the depth in meters, since it should say that. Okay. All right, so our A value, so 3.1, we can say, so that means the distance from the average to the highest is 3.1, and same to the lowest. So this one here actually might, do we have room? I'll interpret it over here. So for this one, we can say high tide is 3.1 meters above average. We could also say that low tide is 3.1 meters below average, but this works right here. And then lastly, our B value is 30, which for this one, it wouldn't make as much sense to interpret the frequency. We could say there are 30 cycles between 0 and 360 hours. But interpreting the period makes a bit more sense. So the period tells us that the tide is operating on a 12-hour cycle. So tide has a 12-hour cycle. All right. Well, that is all for trig. We will do some problems next class. All right.